So what's it really like to learn computer science? We're about to take a look at your very first month.
You know, people have all these ideas about it. Do you have to be some kind of math whiz? Is it all just typing weird symbols on a dark screen? What actually goes down in that first month when you jump in? Well, we're going to find out.
We actually got our hands on the homework assignments for a real Intro to CS class. I mean, this is it. The actual curriculum, the problems students have to solve, the concepts they've got to master. This is the real deal.
So we're going to take you on a super quick tour of those first 4 weeks. We'll go from the biggest, most abstract ideas all the way to your very first working program. You ready? Let's dive in.
All right, week 1. So what's the very first thing you learn? You might be surprised. It's got nothing to do with code. Nope. The first week is all about kind of rewiring your brain. Because before you can tell a computer what to do, you have to learn how to speak the language of problem solving itself.
And that language? It's really built on this one core idea, the algorithm. Now, don't let the word scare you. An algorithm is just a recipe. Seriously, it's a step-by-step guide. But instead of baking a cake, it's the recipe that recommends your next song, finds the fastest way to get to work, or decides what pops up on your social media feed. I mean, our entire digital world is built on these things. And that leads to this huge realization. Computer science, it's not really about studying computers. It's the art and the science of designing those recipes, those algorithms, and then figuring out how to get machines to follow those recipes at mind-blowing speeds. So the big takeaway from week 1 is pretty simple. Computer science is really just a powerful way of thinking. It's all about breaking down these huge, complex problems into small, simple, logical steps that you can actually solve. And honestly, that's a skill you can use for pretty much anything in life. Okay, so we get what an algorithm is. It's this master recipe, but how do you actually, make one? Well, you don't just start coding blindly. Week 2 is all about creating the blueprint first. And to do that, programmers have 2 main tools they use. First, there's something called pseudocode. It's basically just writing out your recipe in plain, structured English. And then you've got flowcharts, which are these awesome visual diagrams that literally map out the entire path your logic is going to take. Check this out. This flowchart is a perfect example. It's like a roadmap for the computer. See those diamond shapes? Those are decision points. They're forks in the road. The program gets to one and asks a question. And depending on the answer, yes or no, it goes down a completely different path. This is how you can actually see your logic before you write a single line of code. And here's that same kind of thinking, but written out as pseudocode. See how clean and simple that is? It's just a step-by-step blueprint that anyone can read and understand, and that clarity, that's exactly what you need before you dive into the nitty-gritty of actual code. All right, so you've got your blueprint. Now it's time for the main event. Week 3 is where you take that easy-to-read plan and translate it into a language the computer can actually understand. Yep, this is where the coding begins. And this right here? This is a rite of passage for literally every programmer on the planet. Hello world. It looks like nothing, right? But it's so powerful. This is that first moment where you realize, whoa, I can actually talk to this machine, and I can make it do things. You know, it's kind of like learning to play guitar. At first, you're just fumbling with chords, right? But then you play your first real song, and it's like, bam, you're making music. That is the exact feeling you get when you run this code and see Hello World pop up on your screen. And hey, check this out. Remember that blueprint we had for adding 2 numbers? Well, this is what it looks like when you write it in C, which is one of the classic programming languages. The logic is identical. We've just translated our plain English plan into the specific grammar that the computer gets. From blueprint to reality, just like that.
So, you've written your first program. Awesome. Now what? How do you start solving problems that are a little more complex? Well, week 4 is where you're handed the 2 most powerful tools in a programmer's entire toolkit: making decisions and repeating actions.
First up, you've got conditionals. Just think of an if-else statement as giving your program a brain. Is the password correct? If yes, log the person in. Else, show an error message. It's that simple. But that simple idea is the foundation for pretty much all intelligent behavior you see in software. And with just that one tool, suddenly students get this kind of superpower. They can solve all these real problems, like figuring out if a number is even or odd, or if a year is leap year.
Every single one just boils down to a series of simple yes or no questions.
But the second tool is maybe even more powerful. It's the loop. I mean, why would you ever write the same line of code 100 times when you can just tell the computer, hey, do this 100 times for me? That's the magic of loops.
They are the engine that drives automation.
And once you have loops, a whole new world of problems just becomes easy. I mean, imagine trying to write out a multiplication table by hand. Ugh, what a pain. With a loop, it's like 3 lines of code. You can do tasks in seconds that would take a person hours to do.
Okay, so we've gone from these big, abstract ideas to making blueprints to writing actual code that solves real problems. But what's really going on underneath it all? Well, in the last part of your first month, you get to peel back that final layer and see the absolute foundation of everything.
So we humans, we live in a base 10 world, right? We have 10 digits, 0 through 9. But a computer, at its very core, is just a massive collection of tiny switches, and each switch can only be on or off. That's it. So their entire universe is built on just 2 numbers, 1 and 0. This is the binary system.
And here's how it works. When a computer sees the number 26, it doesn't see a 2 and a 6. It sees this sequence of ones and zeros, 11010. And here's the really wild part. It's not just numbers. Every single letter you type, every pixel that makes up the image on this screen, every sound coming out of your speakers, deep, deep down, it's all just an impossibly long and complicated pattern of ones and zeros.
So there you have it. From the big picture philosophy of an algorithm all the way down to the ones and zeros that the machine actually speaks, you've just blasted through your first month of computer science. You've now got the fundamental building blocks to solve problems and create some really amazing things. So the only question left is, what problem would you solve with them?